Hi, this is Jeffrey. This is 2015 FRQ number 6. So for FRQ number 6, they give us the Maclaurin series for function f is this thingy, and they even give us the expansion, which is this thingy, with this being the general term. It converges to R, where R is the radius convergence of the Maclaurin series. And so part A wants us to use a ratio test to find R. This is a really simple problem. All you need to do is plug it into the formula. So the formula is x to the n plus 1 over x to the n, where x is just the general term. So let's do that. Negative 3, n plus 1, n plus 1, n plus 1. Okay. And then, so shortcut for dividing by something, a fraction, is to just multiply by the reciprocal, of course. So let's do that. The reciprocal of this is negative 3 n minus 1 x to the n over n. So we know n plus 1 over n converges to 1. We can prove this using this. We divide each by n, and we have 1 over 1 plus 1 over n. Limit as n approaches infinity, it's equal to 1. So we know that's 1, and these two just cancel out because when you multiply by 1, you get the same thing. And these two also cancel out, so the n parts cancel out, right? And we're left with negative 3 to the negative 1 on the bottom, which is just negative 3. And on the top, these n's cancel out for x, and we're just left with x. So then we know it's from negative 1 to 1, according to the ratio test. And we have 1/3 larger than x. Whatever, it doesn't really matter, over 1/3. Now, a common mistake is to confuse the interval of convergence with the radius convergence, or maybe to not notice. But, being great Calc BC students, of course, we don't make that mistake. So we have r is equal to 1/3 of the radius. Right, so part B. Part B wants us to write the first 4 non-zero terms of the Maclaurin series for f prime, the derivative of x. Express f prime as a rational function for x within the radius convergence. So let's do the first part. The first part wants us to just write the first 4 non-zero terms of the Maclaurin series for f prime of x. So we know the first 4 terms of f of x, and finding the derivative of each gives us the Maclaurin series for f prime of x. So let's do that. First term is, they give us up here, x. Second term, third term. Now we have to find the fourth term. Wow, so hard. And okay, sorry. Knowing that it starts at n equals 1, we know that the fourth term is 1, 2, 3, 4. We plug in n equals 4. So let's do that. We have negative 3 over 3, which is just negative 27, over n equals 4, x to the fourth. Taking the derivative of each term, we get 1 minus 3x plus 9x squared minus 27x cubed. Right. Now we have to represent it as a rational function. So we know the formula for a power series is 1 over 1 minus x, infinity, n equals 0, x to the n. So let's do that. Right, so this is for the general term of the series. So the general term for f of x is negative 3 m minus 1 to the n, x to the n. So we need to find the general term for f prime of x, and that's just a matter of taking the derivative, which is just moving it down, and then using the power rule. We get negative 3 n minus 1, x to the n minus 1, from infinity to n equals 1. Now, this looks kind of similar to this, but it's not exactly similar, so let's shift it left 1 to make it easier. N equals 0, and 3, n, x to the n. Now, this is looking a lot more familiar, the x to the n. So, we have this. Now, x is just equal to negative 3x, and we have 1 over 1 plus 3x. Alright, so that's the answer. That's what we get for the answer. Okay, now part C wants us to use the first 4 non-zero terms of the Maclaurin series for e of x, then use the Maclaurin series to write the third degree Taylor polynomial for g of x, where g of x is e of x times f of x about x equals 0. So first, let's find the first 4 non-zero terms of the Maclaurin series for e of x. So this is one of the formulas you should memorize for the AP test, and all it is just x to the n over n factorial. So let's do that. We have 1 over 1 plus x squared over 2 factorial, which is just 2, plus x cubed over 3 factorial, or 6. Now, the second part wants us to find a Taylor polynomial centered at 0. So that's just, by definition, that is what a Maclaurin series is. So no worries there. Then it wants us to find the third degree Taylor polynomial. Knowing that it's the third degree polynomial, if anything goes over, like if it's anything is raised to more than 3, then we don't have to include it. So if we want e of x times f of x, that's just multiplying the two series. And they gave us the series earlier over here. So all we do is multiply them. That is x minus 3 half x squared plus 3x cubed. So now all this problem is just distributing, and we get x minus 3 half x squared plus 3x cubed plus, next this term, x squared minus 3 half x cubed. Now anything above degree 3 we don't need because it's a third degree Taylor polynomial, as I said earlier, and so we don't need to multiply these two. And finally, x squared over 2 plus x cubed over 2. Now we don't need to multiply these two. So solving this, or canceling things out, we get x minus 1 half x squared plus 2x cubed. So I hope this video was helpful. If you need more practice, you can look in the links below.